Welcome. This is a video, an informative video. It's on connections between plasma screens and LCD screens with the Chemistry 12 textbook. Please do not pause this video with your screen on for too long. Keep watching and you'll find out why. Let's get on to the video. Please enjoy.
What's up guys, it's Tom and Tom here, and we're going to talk to you about plasma and LCD screens. So we're going to make 3 connections for each type of screen. Let's start it off with the first one. Alright, so plasma is the 4th state of matter. State of matters being liquids, solids, or gases. That's right, you heard me. 4th state of matter. You thought there were 3, didn't you? Plasma is an ionized gas. So what that means is enough energy is supplied into the gas, which allows the electron to move freely within the atom. And this allows the atom to separate into its ion and electron. But in this case, plasma allows both of them to exist at the same time. Now, how is this related to the chemistry textbook? Ionization energies, as we learned in around page 153, 154. This is basically how much energy it takes for it to ionize an inert gas or any other gas. So plasma screens, well, plasma televisions, basically use neon and xenon to produce color to what we can see. Now, neon has a first ionization energy of 2,080.6 kilojoules per mole, while xenon has its first ionization energy of 1,170.4 kilojoules per mole. 1,000? Yeah, that's a lot of energy. But the plasma screen must be able to provide all that energy in that each cell, so these gases start ionizing to create the plasma, which we're going to use to basically produce the light. So I hope you got that. Let's move on to Tom's connection. What is an LCD, you might ask? LCD stands for Liquid Crystal Display. LCD uses light modulating properties of liquid crystals, and it's battery powered. LCD screens contains electrodes. Electrodes are conductors and are made from indium tin oxide, ITO. These electrodes are aligned to liquid crystal molecules, and they supply power. Power! Simply put, it's basically what powers them up. I'm sure you've all wondered, how is color produced from all these TVs and screens, and especially in plasma, from gases? Colors? Rainbows. You've all seen this type of light work. How this color forms? You've seen neon lights. They're all fluorescent lights. You've seen all those pretty different colors. Fluorescent means emitting light from exposure to radiation. Example, ultraviolet light. It's from an external source, from plasma in plasma screens. Now, ultraviolet light, we receive it every day. It comes from the sun. And basically, the sun, what it does for you is that ultraviolet light, it does a lot of bad stuff for us. We have ozone to protect us. But in plasma screens, the plasma actually produces the ultraviolet light. We also learned in class that each gas, when it's ionized, it produces its own color. In this case, neon, for example, shines a red-orange color when ionized. And we know this from the emission spectrum from red to violet. And that's basically what each gas would do when it's inside its own cell inside a plasma screen. However, since there's a small amount of gas in each cell, the color is not very bright. I mean, compared to the sun, it's not really bright enough to shine over what the actual color we see from the screen is. Each cell is filled in with the gas, and when the gas is ionized within the cell, it produces plasma, and this plasma is the actual thing that releases the ultraviolet light. So how do we get visible light then? Ultraviolet light, we can't see it. That's where the colored phosphors come in. So each phosphor is colored as red, green, or blue. Basically the RGB of the TV. Now these phosphors are the stuff that are actually fluorescent. They absorb the UV light from the plasma and they show it to us as visible light. Since it's colored, that's the kind of color that we see from the TV, the red, the green, and the blue. So basically that's how colors comes out from a plasma TV. The gases are ionized and the plasma produces the ultraviolet light. However, the colors of the gas itself are not bright enough for us to see within the TV. And the phosphors within the cell, it'll shine the visible light that we want to see, and through pixels, that's how it creates images for us.
The difference between the potential energy at the anode and the potential energy at the cathode is the electric potential. The measurement for it is volts. We know that electronic products use volt. That's why we have these plugs. By controlling the voltage applied to the liquid crystal layer in each pixel, light can pass through in different amounts. This makes different levels of gray. This is mainly shown in these.
What about those annoying screen burn-ins? Is it exothermic? Technically, if you think about it, I said plasma is an ionized gas. So the ionized reaction of neon would be neon plus energy would produce neon ionized and a free electron. This is an endothermic reaction. But why, Tom? Why would it burn images if it's cold? We'll get back to that later. But you might also be wondering, if it's ionized and there's nothing around it, then shouldn't it become back to what it was before? Since there's such a small space and it's only one gas that's getting ionized, that's why it becomes plasma. This allows electrons to stay separated from its atom, as I stated before. And I also stated before that plasma generates UV light. Now the UV light generates the heat, basically almost up to 1,000 degrees Celsius. Now that's hot. I mean hot if you know what I mean. However, that's not the cause of screen burn-in. But you're not telling me about what causes it, Tommy. What's the cause of screen burn-in? Jeez, relax, hold on, stop crying. I'll tell you now. Over time, phosphorus begins to lose its brightness. Basically, it has a half-life. If one area of phosphorus are used way more than others, that specific area begins to age faster. One main source of burn-in that most people should know by now is that all those TV channels you watch, most of them have like a little logo right here. I mean, that stays there all the time. What does that do? I mean, what it does is it basically kills off the phosphorus that's basically there. It lights it up all the time, and this logo, it's always going to stay there. It's going to keep it lit, and it just kills it off faster, and it's going to reach its half-life faster. So what you want to do is basically try to watch channels without the logos. That logo is just going to leave a little lighter part on your screen. So even though you think, shouldn't the color cover up the screen burn then? Wrong. When I said it had half-life, if you kill it faster, it's going to be a bit lighter than the other parts of the screen. So the colors are lighter than the other brighter colors on the screen, making a little after image on the screen. And when I see airports do it, it becomes like this. What a waste of a TV! If you don't want your screen to go from this to this, then I suggest you listen to what I say. Don't leave your TV on a still screen. But don't you think it's surprising that an endothermic reaction can do all that?
So think about it. Where do we get light? Such as
The sun.
and the light bulb. LCDs are basically reflections of light that create images. According to Einstein, packets of light are called photons. No, not like that! LCDs reflect the light to create images. The direction of light is manipulated by electrodes, voltage, and the filters. If light wasn't a photon, we wouldn't be able to do this.
Thanks for tuning in to our
LCD and plasma screens. We hope you enjoyed our video.
We hope it was informative.
This is Tom.
And Tom here. Tune in next time for our video that'll never come.
I really hope you enjoyed that video. Thanks for watching, and here are some bloopers.
And since it's colored, it'll shine the color of which it's colored. So basically, red shines red, green shines blue. Green shines blue? What the heck? That's hot! Hotter? No, not hotter. Cut it!
LCD uses light modulating are made from indium tin oxide. These oh my. 3, 2, 1.
to our next video. Tune in next time. Tune in next time for our video that will never come.
Exactly.
Okay.